Today we're going to be talking about the altitudes in a triangle. Now, what is an altitude? An altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side, depending on the triangle. It's also called the height of a triangle. So here are some examples. If you look at the triangle on the left, triangle PQR, you can see that the altitude is drawn, that red segment there, and you can see how this is perpendicular to the opposite side PR coming from point Q. Now, you can also see in the triangle on the right there that this altitude that's drawn is outside of the triangle. So in this case, we have an obtuse triangle, and if you draw from point Q and you want to draw a line that is perpendicular to the opposite side, the only way you can do that is to extend PR out with that blue line there in order to draw that. And so that's why in our definition, we say it's the perpendicular segment from the vertex to the opposite side, so directly to PR like the one on the left, or it's to the line that contains the opposite side. So that blue extension there is containing the opposite side. Now, for altitudes of a triangle, the point at which those three intersect is what we call the orthocenter. So the lines containing the altitudes of a triangle are concurrent, and that point of concurrency is called the orthocenter. Now, if you take a look at these triangles here, this first one, we have an acute triangle, and you can see that the altitudes are all drawn, and you can see they all intersect at point P. Now, point P in this case is going to be inside of the triangle. The orthocenter is inside of the triangle when you have an acute triangle. In this next one, the right triangle, you can actually see that the three altitudes that are drawn for this triangle, two of them are actually exactly two of the sides because you have a right triangle. So in this case, the place where all three of those lines, all three of those altitudes intersect is at point P, which you can see is exactly on the triangle. In this third one, we have an obtuse triangle, and drawing all the altitudes, in some cases extending some of those sides of the triangles in order to draw the altitudes, we see that they intersect at point P, which is outside of the triangle. So for all of these, the altitudes were shown in red. Notice that for the right triangle, the legs are also the altitudes, and then the altitudes of the obtuse triangle are extended to find the orthocenter, and that orthocenter ends up outside of the triangle. Now, isosceles triangles, they have a special feature, now that we've talked about all these different parts within a triangle. So for an isosceles triangle, this line that's drawn here, BD, is actually the perpendicular bisector. That means that it bisects line AC and it forms right angles. So BD is perpendicular to AC, it's a perpendicular bisector. It's also an angle bisector. That means that ABD and CBD are equal to each other. BD also is the median because you can see that it is drawn from the midpoint of one side, D, to the vertex of the opposite side, which is B. And it is also an altitude. It is the height of the triangle. So again, this only occurs with isosceles triangles, but the perpendicular bisector, the angle bisector, the median, and the altitude all happen to be the same exact segment. Now, just as a summary of all the different parts that we've talked about up to this point, we're going to fill out this chart. And so we have the different parts of a triangle, the midsegment, the median, perpendicular bisector of a side, angle bisector, and the altitude. We'll talk about whether or not they are concurrent, if they are concurrent, what that point of concurrency is called, and then any other special attributes of point of concurrency. So let's start with the midsegment. So midsegments are not concurrent, So in terms of the point of concurrency, this does not apply, and no other special attributes. Now the medians, those are concurrent, and the point of concurrency is called the centroid. Now the centroid divides the median into two parts, where one section is going to account for 2/3 of the distance, and the other side is going to account for 1/3 of the distance. So the distance from the vertex to the centroid is 2/3 of the length of the entire line, the entire median. Now the perpendicular bisectors of a side, those are concurrent, and we call the point of concurrency the circumcenter. And the circumcenter is equidistant from all vertices of the triangle. Next, we have the angle bisectors, and these are concurrent, and we call that point of concurrency the incenter, and that incenter is equidistant from all sides of a triangle. The last one is the altitude, and the altitudes are concurrent, and that point of concurrency we just said is called the orthocenter. And there's nothing in particular special about the orthocenter besides that is the point of concurrency.